Then, of course, looking at information, and it's kind of small writing here, but samples were received intact at 3 degrees Celsius on ice with chain of custody documentation. That's going to be an important thing to know as at any level of reviewing lab results, that they were analyzed within prescribed holding times. One of the sample types of analysis I can think of off the top of my head where holding time could be sensitive is for pH. And maybe Patty can think of some others. And then this section here, comments. And on this report it says no significant observations were made. I have a quick story for you. It's been many, many years ago. I was overseeing UST removal, and it was just a small used oil tank. Just take a couple of samples, one at 2 feet, one at 6 feet underneath the tank, and the guy, he was kind of a rough and tough contractor. He, scooped up the samples with the backhoe, put on his gloves, shoved it all in there, and then closed it all up, and threw them in the ice chest, and then he would throw a chunk of dry ice in the ice chest, and because he used the dry ice to inert the tank. So then I was reviewing the results, and I was looking through, and I thought, oh, okay, non-detect, non-detect, okay. Looks like they didn't have any leaking, and it kind of made sense because I didn't see a lot of staining in the soil, that kind of thing. But then I looked at the comments, and it said, sample jar broken. So the sample jars had broken because they were right next to the chunk of dry ice. And so those samples, I had to question the validity of those results because the sample jars arrived cracked at the lab. And I might not have noticed it if I wasn't reading through that data. Okay, so making sure the page numbers are there. There is a glossary of terms, and Patty's going to go through several of the definitions right now, and they're in your slide notes. But you can find this. I just picked a bunch of the terms that I always wondered what they meant, but you may have other terminology that you wonder, what that means. You can actually look up this glossary of terms in SW846, Test Methods for Evaluating Solid Waste, Physical Chemical Methods, EPA publication, and everybody's, maybe not everybody, but what we call that is SW846. That's what that stands for. And there's also, you can Google it on DTSC's website, Environmental Chemistry Laboratory ECL Users Manual. Or you can call the lab manager, and I'm sure, hopefully your lab manager's as nice as Patty. One of the things that if you don't get with the right person, you can just keep trying, well, when I speak to your supervisor, I really would like to talk to the person who's in charge of running the samples. I have some questions, and usually they're very willing to help you understand. So Patty's going to go through a few terms here. Please, if you think of any questions, we'll get those answered.
Okay, matrix, the component or substrate which contains the analyte of interest. Did you send me soil? Did you send me water? Did you send me some kind of sludge or product? We're going to put it on our laboratory reports what we think this is. Usually water, soil, and sludge, or product of some sort, or waste material are the most common ones that we're going to be getting. You can also send in air samples. We don't do a lot of air testing at our particular lab. We have another sister lab that does that for us. It's best to keep them separate. For holding times, the methods specify how long you have between when you take the sample and when we start the extraction or the analysis. There's different types of tests and different types of hold times. But they're trying to capture the most real concentration that's in your sample. And if we don't make that hold time, there's a lot of questions then. Well, is it really what was in that sample to begin with, or did you put it in the cooler and forget about it and we got it warm 3 weeks later? There's going to be a difference, especially if you're looking for something volatile like benzene. If I don't get it analyzed within 14 days or 7 days, depending on what you're looking at, then the results may not be valid and you may not really know what's in there, and it's going to cause a lot of questions and you may get in trouble for it, and that's not something you want. But we do try and meet holding times. If you let me know what test you're doing, I can tell you what holding times there are. And it's something that's on our website. We have all sorts of forms we can send out to people too to give you just, okay, these are all the methods we run. Here's all the hold times for them. Preservation. Almost everything has to come to us less than 6 degrees C. We take 0 to 6 degrees as our normal. Dry ice is not recommended, obviously, because it breaks glass samples. Try not to use dry ice. Regular wet ice is fine. Put things in baggies so they don't leak or get wet or anything, and that'll help you out too. Quality control data. Okay. What we do is we have to prove that our data is valid. When we ran your sample, how do you really know that the results we gave you are correct? And the way we can prove it is we'll run a blank to show you that everything was clean. We'll show you spikes to show you that if it was there, we would have seen it, and that we would have seen the correct amount, and that we can see the correct amount consistently. And these results for the quality control are on separate pages from when your lab results are. And a lot of times I'll get people who start reading me these results and they're freaking out because of all these high concentrations. Oh my God, what's in my sample? Well, it turns out they're reading the quality control and the spike results. And so of course there's something in there because it's our spike results. So just give me a call if you have any questions, if you have a report from me and you don't understand the results or it doesn't make sense to you where things are on what page. And I'll just sit there and walk you through it and we won't have any problems that way. Method blanks. What we'll do is we've got ultra pure clean water in our laboratory, and we've also got clean spike sand to use. We'll take this, the sand, and we'll treat it exactly like we do the samples, or we'll treat the water, our clean, clear water, just like the samples. So if there's any kind of contamination anywhere in our process during the preparation analysis, we're going to see it in the blank. And then we're going to know that your results are not valid, and we have to start all over again, clean it up, and get it going. Things that you typically see in method blanks are going to be, if you're looking for volatiles, you're going to see acetone and methylene chloride, potentially at lower levels. Zinc for metals, easy to contaminate with zinc. So those are things that you're going to look for in labs. If you see real high concentrations, look back at the QC pages and make sure that it's not in the blank too. If you have it in your blank, you're supposed to flag all the results saying, hey, there's method blank contamination, or better yet, the lab should start over and just give you a new set of results where the blank is clean. Detection and reporting limits. If you give me a sample that's got % levels of benzene in it, and then you ask me to look at 0.5 ppb vinyl chloride, I'm not going to be able to do it. In order to be able to see that benzene and not have it completely saturate the detectors on the instrument, we're going to have to dilute it down to where we can see it within our calibration range. And when we dilute it down, that means it's less sensitive to all the stuff that's non-detect. And so the non-detects are going to have higher reporting limits. So instead of seeing at 0.5 ppb, we're going to see non-detect less than 50 ppb. And that may not meet your requirements. So if you see a dilution factor, I know that we saw those pages a while ago, and there was a dilution factor column. If it's not 1, if it's something higher, that means we had to dilute the sample. So that's a flag to you to make sure you go look at those reporting limits and they're not too high. Do you have a question? For the sample that was diluted 98 times? Yeah, if you've had high concentrations of something, again, if it causes interference on the instrument or it saturates the detector, we can't see anything else then if we just run it straight with no dilution. So we have to go back and do dilutions on it, otherwise your results won't be valid.
Then you have to multiply the results times 98?
We have to multiply the MDLs, reporting limits, and the results. We've already done that on our reports. We're just letting you know that's what we did for a dilution factor. So it's this there as a piece of information. It's not for you to go through and multiply everything out again. I'm sorry? It's already been adjusted on the reports for the dilution factor, correct. Relative percent difference. Oh, I'm sorry, was there another question? No? Okay. Relative percent difference. That's just letting you know that we can get the same answer multiple times. So you've given me one sample, we're going to get within 20% every time we run it. So if I get 9 one time, 10 the next time, 11 times after that, you know, your result's not going to be exactly the same every time we run it. There's a little bit of instrument fluctuation each time. But there have to be within a certain relative percent difference, otherwise the data's not good. We have to go back and find out maybe the system was getting too hot, too cold, too hot, too cold. Maybe there was something wrong with the the current going through the instrument at the time. So there's things that we have to check and make sure that we've got our system under control. So relative percent difference is one of them. You should see results for relative percent difference in your QC section. Laboratory duplicates, again, same thing. We want to see how, if we can get the same result multiple times in a row. If you don't see the same result, you send me a sample and then you send me another sample and you call this one A and this one B, but they're actually the same thing, and you ask me to run it 2 times and I get 20 ppb for this one and non-detect less than 0.5 for that one, something's not right. You got to make sure that those results are consistent. They're not going to be exactly the same, but they're going to be close. Matrix spike duplicates. People love these things. What we do is we'll take a batch of 20 samples at the most, and associated with that one batch, we're going to have our method blank. We're going to have a group of MSMSDs. What we do is we take a chunk of your sample and we analyze it, not treating it, not spiking it, not doing anything. So we're analyzing your sample and giving you your results. And then we're taking 2 more portions of your sample and we're putting a known amount of, say, lead in each of them. And then we're doing the same prep analysis and everything and running that. And we're going to make sure that we can see the amount that we put in there, plus whatever you had in there too. So that's our matrix spike duplicate. That tells you whether we're seeing interference from something in your sample. And if we don't get 20, we only get 2. Or if we get 200, then we know there's something in your sample that's causing interference. The drawback for this is that we do 1 MSMSD set per batch of 20. If it's not your sample, it may not mean anything to you. So make sure that it's your sample if it's got some issues on it. Got everything for?
Oh,
one more?
Method
One more.
spikes.
Okay, method spikes. Now, blank spikes, they're also called, or laboratory control samples. What we'll do is instead of taking a portion of your sample and spiking lead into it, we'll take a portion of either clean, clear water or clean sand. We'll spike into that and run it through and make sure we get exact. We should not see any interference issues. This should give us back exactly what we put into it. If we don't get that good LCS recovery or method spike recovery, then we know we have a big problem. We cannot report the data. We've got to scrap that batch and start all over again. It's very important that this blank spike be right because there shouldn't be any interferences or any issues on it. And the last one, the blank data. Yes, checking for contamination. We already touched on that a little bit, but definitely make sure if you've got detections in your sample, go back and look at that method blank to make sure that it's clean. If it has a detection about the same level as your sample, then you've got problems with that data and you're going to have to go back and ask for it again.
So the difference between a method spike and a matrix spike?
Once the method spikes into a blank, clean, clear matrix, and the matrix spike is into an actual sample.
Okay.
Any questions?
Okay, great. All right. They're thinking of their questions. All right, chain of custody, and really the information on this. How many of you in the class have had to prepare an enforcement case and use sample results as your evidence? Oh, not very many, just a few. Okay, how many of you are a generator, hazardous waste generator, a facility representative, and you collected the samples and you maintain that data to make sure you can prove that you've done your waste determination and you've made sure your chain of custody is attached? A few. Oh, more. Okay, good, good, very good. So the chain of custody is one of the most important pieces of a laboratory report because it's sort of the manifest that goes with the sample. So you're tracking who held that sample, who was in control of that sample. So that can come up as an important issue as an inspector. If you're, say, collected an authoritative sample and you end up having to prove the violation, you have to be able to show that your sample held its integrity. There should not be any doubt that you maintained a very good sample. That's utmost important. So you have to make sure you sign it properly, keep it secured, keep it preserved under ice or whatever is needed. You have to mark specifically instructions for the laboratory because once Patty or your lab manager receives this lab result, this chain of custody, they are using this to figure out what they're going to do with your sample. So it's important to denote whether it's a grab or composite sample. It's important to note your sample number very clearly and the sample location. And then any other information that might be necessary. Can anybody think of any other information that might be good for a lab to know? on their chain of custody? Sorry? What kind of test to run? Very good. What method you're going to use. And I've done this before, I forgot to check the column. Patty's just supposed to read my mind and know that I wanted STLC on that liquid sample, or whatever it may be. So you got to make sure you check the boxes as to which method. The other thing that might be good to note is the concentration of that sample. When a laboratory receives a very concentrated sample of, say, some type of a volatile, a solvent or something like that, and it's all solvent, that if they don't know that in advance, it could mess up their equipment. And it's important for the safety of the laboratory personnel. If there's issues, health and safety issues with that sample, it's really important to note that in the comments on the chain of custody. And we'll talk more about that later. All right. There was a question earlier about figuring out what methods. There are a lot of sources for you on DTSC's website, Department of Toxic Substances Control, the state's website, EPA's website. The laboratory, and I'll have Patty talk about it in a minute, but as far as how a laboratory becomes certified and they have certain methods they're able to run in their laboratory. It's really knowing information about the source. I'm just going to give you a quick story. I think sometimes, I know I learn by hearing other people's experiences. I had a case where a facility, and I'll talk more about this example later, but in general, the facility was making implants. So they had titanium metal, and they're like knee joints and stuff that people get a new hip or a new knee, and so they were made of titanium metal. And so they were doing a surface preparation on that piece of titanium. Obviously, they're putting it in someone's body. It has to be clean and pure. So they did a lot. They used a lot of hydrofluoric acid, nitric acid, and then they were doing adjustment and treatment of that waste and neutralizing that waste. And because of the constituents of the titanium hexafluoride, when they were neutralizing that waste, it ended up creating fluoride salts, and it was building up in this tank over time, where over the years, this tank where they were putting this waste in, it built up a layer of about 5 feet of sludge in the bottom of this. It was probably about I think it was around a 900-gallon above-ground tank. So it built up this layers and layers and layers of fluoride salts. So if you're aware of the state's thresholds and the regulatory limits, fluoride salts is something that is considered a hazardous waste above certain thresholds. So we tested our samples for fluoride salts, and I'll talk a little bit about that later, but that's what we tested our samples for using EPA method 300. So when you look in the statement of reasons when they developed Title 22, way back when, it will say in there what they thought was hazardous, like lead or chromium or all these 17 metals that they identified, fluoride salts being one of the items. And they said, well, this is the method that should be used to determine if you have fluoride salts in that waste stream. So in that proposed statement of reasons for the regulations, they said EPA method 300 is the preferred method. So then when you look up all the methods for testing fluoride and fluoride salts, there's a lot of different methods for testing fluoride. There's wastewater treatment that has fluoride as a concern, like fluoride ions and things like that. So some people are looking at it from one perspective, say the wastewater treatment people, they might be testing for fluoride ions, and that's a completely different test method. We're looking for fluoride salts, so that was EPA method 300. So the facility, we did our tests, fluoride salts, it was way over, obviously super concentrated. And then they did their sampling and they did fluoride, they tested for fluoride, and they said, well, no, you're wrong, it's all below the threshold. So we started looking at the method that the facility used, and they used something, method 6240 or something. And of course I found the website and looking at to look up that method, and it specifically stated this method is for checking for fluoride ions. This method should not be used to determine the level of fluoride salt. So it was new to me. The facility didn't even realize that they had all that time not been running the right test, and they honestly did not think that their waste was hazardous. They were hauling it as non-hazardous. So having the wrong method was a big error, and it affected them greatly. So let me have Patty talk a little bit about how a laboratory gets certified and what they do for that process.
State of California certifies laboratories, environmental laboratories, to perform the analysis that we do. We have to prove that we know what the methods are, that we have standard operating procedures, all outlining exactly how we run the method in our laboratory. We have to get audited by the state to make sure that we're doing the test right. We have to prove that we've trained our employees right, that we have records of all the training. There's a lot of steps involved to make sure that we're doing the tests properly. There are multiple different tests, like Sandy was saying, for different types of analysis, and we may be certified for multiple tests. So if you know specifically what you're looking for and that you need us to do a certain test, let us know, and we'll let you know if we have the certification and training already in place too.
Thank you. Okay. And then I remembered the other part of my story when I asked, because I felt bad for the facility that had been testing all this time, spending all this money, and not realizing that they weren't running the right test. And so I actually called their lab, and I said, well, why would you run this test? And what was the reason? And they said, oh, well, we're not certified to run EPA method 300. I was like, oh boy, okay, that's not good. So just something to keep in mind, making sure you choose the right method as a facility and as a regulator in reviewing sample results, making sure the right method is chosen. Okay, you guys ready? Are you still awake? Okay, let's do some more questions here. All right, so here we go. What does ND stand for? I'm just give the answer.
Such habit.
Good. Oh, you're awake. Okay, 56. Okay, 4 people left. No. Okay. All right. Wow. Woohoo. Good job. Non-detect is the answer. Very good. All right, here's another one. See if you were listening to Patty. Well, maybe I won't tell you this now, but this is an open book test if you want to look at your notes. Okay? You know, I might have messed up on this one. Yeah, it could be either. Okay. Yeah, I need to fix that. Okay, well, if you picked 1 or 2, you're correct. It could stand for matrix spike or method spike, so I need to change that question. Very good. All right, MSD. What does MSD stand for? Is that right? Could it be either for this one too? Okay. Yeah, I got to fix these questions. Okay. Sorry. Okay. So if you answered 1 or 2, you're correct. Method spike duplicate stands for MSD, also matrix spike duplicate. Okay. Oh, I'm sorry. What did I say?
Right.
Okay. So, oh, yes, you're right. That's correct. Okay, very good. All right, RPD. What does RPD stand for? Very good. Okay, most of you got it right. We're talking about laboratory reports here. These other things that are on here might be perfectly good acronyms. So, but for this class, it's relative percent difference. All right, very good. Okay, any questions? How's everybody doing out there? Very good. All right, so interpreting lab results. What do they mean? To what standard do you compare the results? And this is something not just for inspection staff, but it's important for facilities to know what standard. So when you get these reports back, now what do you look at to see if those results are good or bad? You could call your CUPA inspector, but maybe you don't want to. Maybe you want to figure it out yourself. And really, that's what we need to do as CUPA inspectors, is to point the facility, as in the sections in Title 22 of the California Code of Regulations, where they can review those tables and make the determination themselves as to whether their samples are hazardous or not. So I'm going to talk about that, and making sure you run the right test. And why is it so important to know as much as possible about the source? Anybody? You need to know what tests to run, right? You really got to know. Even when you have the results back, you need to know. And I'm going to talk to you a little bit about that, because there's some footnotes in the tables, the regulatory threshold tables that I'm going to show you. There's some footnotes in Table 2 and Table 3 that say the exception to the table. You know, there's a few barium and chromium that if you get back results, you may think it's over the threshold, but it may not be, depending on the type of barium or chromium you have. So I'll talk about that in a minute.